Hello everyone. Today I continue my long, arduous journey to become a master of arrays. Today we are in the category of searching. So we have valid mountain array. So what is a valid mountain array? Well, we have a nice picture here that shows us what a mountain array is. You can see it is strictly increasing, and then it is strictly decreasing, making a mountain. Here is an example that is not a mountain array. You can see it is increasing, and then we have two numbers that are the same, so it is not strictly increasing. And we also have this rule that it cannot be less than 3. Must be greater than or equal to 3. So example 1 is false because it is a length of 2. It has a length of 2. Example 2 is false because it is not strictly decreasing. It is strictly increasing, but after it gets to the peak, it stays the same. So we cannot say this is a mountain array. Here is a good example of a mountain array. We increase to 3, and then after 3, we continue to decrease. So how might we judge if something is a mountain array or not? Well, we can have a pointer, and we're going to look at this index, and we'll look at the next index, and then we'll ask, is this index less than 2? If it is, then we continue. We move our pointer. So we move the pointer to 2, and we ask, is 2 less than 3? And so that's good. And so then we ask if 3 is less than 4, and it is. And then we ask, is 4 less than 5? It is. And so we keep moving the pointer until it is not true. So 5 is not less than 2, so we stop moving the pointer. But what about strictly decreasing? Well, we can have 2 pointers, and we start from this side, and we ask, is 0 less than 1? It is. We move the pointer. Is 1 less than 2? It is. We move the pointer. Is 2 less than 5? It is. We move the pointer. Is 5 less than 4? No. We stop moving the pointer. Now we ask, is left and right equal? And if it is, then we have found a mountain array. The pointers stopped at the same place, and the pointers tell us, well, they would not stop at the same place if they were not strictly increasing from the left side and strictly increasing from the right side. So let's try to implement this. So first off, a valid mountain array, if the array.length is less than 3, then it is not a mountain array. Return false. Now let's implement a 2-pointer solution. So we're going to have a left pointer. Let left equal 0. 0 is the first index on the left side. Now we're going to have a right pointer. The right pointer is the last index. So array.length, the length of the array is 1, 2, 3, 4, 5, 6, 7, 8. but the index is 1 less than the length because computers start counting from 0. And then we're going to start moving our pointer while our conditions are met. So let's move the left pointer while the current element is less than the next element. So while array left is less than array left plus 1. So while the value at index 0 is less than the value at index 1, then we can move our left pointer, and we do the same thing for the right pointer. While array right, while array right, so we're going to go from the right. So first off, array right is going to be this one at 0, and we want to move this way while array right minus 1, which is here, is greater than. So while array right is less than array right minus 1, then we can move the pointer. So we're doing the same thing but in reverse. So array right is 0, and it should be less than array right minus 1. Now we need to check if they stop at the same place. So if left equals right, then we can return true. Else we return false.